Hi, so in this lecture we will discuss how to reverse a linked list, but this time we are going to take the iterative approach. Okay, so let's see how we can use this approach to solve this problem iteratively. So let's say we have this linked list. The idea is very simple. You need to go to every node and reverse this particular link. Okay, so let us start from the head node. So this is head, and let me take a pointer variable called as current, which is initially pointing to head. So this current we are taking to iterate over all the nodes on the linked list. Okay, so what we want is every node should point to the previous node. Okay, so I also need to create a variable called previous, that is in the beginning it's going to be null. So what you can say current arrow next should point to previous. That means you will change this link, the next will point to null, but doing this step you will lose the address of 2. Okay, so that means you should also store the address of this node first. So you can create another temporary variable. So you can say, okay, I have a temporary variable that is storing the address of the next of current node. So I can say that is going to be current arrow next. So now we are fine. We will not lose the address of 2 because we have already stored it in temp variable. So this link is gone. Okay, and now the same thing we need to do for all the nodes. Now what we want is this current should go here. Okay, so this becomes current, and this previous should come here. So this previous should come here. So what I can say is current should go to temp. Okay, and previous should come to current. So this step again should be done first. Why? Because if you update current, then previous will go to the wrong index. So first bring previous to this location, and then you update the current node to the temp node. So what is going to happen is now you have previous here, current here, and if you put all the statements inside a loop, okay, then you will see temp is this node, and we are doing current arrow next equals previous. So this link is established, previous equal to current, so we bring previous here, and current equal to temp, so current comes here. In the next step, temp equal to current arrow next, so temp goes here, current arrow next is previous, so this link is established, and previous equals current, so previous comes here, and current equals temp, so current is now at this location. So what we do, temp is now null. Okay, so temp goes as null, current arrow next is previous, so this link is established, and we say previous equals current, so previous comes here, and current equals to temp, so this current is equal to temp. Okay, so this current also becomes null. So finally what we have is we will stop at this particular point when the temp is not equal to null, or when the temp is null we will stop. Okay, we can put a condition like while current is not null, something like this, and finally we can return the last node, that is the previous node, as the head of the linked list. Okay, return previous. So this is how we are going to do it. Okay, so if you want a brief recap of how things are moving, it's pretty simple. So we have previous, current, and temp. So at every step current points to previous, so this goes null, this link goes off. In the next step, this is how PCT moves. Okay, so current points to previous, this link is established, this link is gone, and PCT moves, PCT. In the next step, current points to previous, and that's it. Okay, and you stop because temp is now. Finally, PCT will also move, current and temp both will be null, and finally previous will be the head of the linked list. So you can verify this yourself, and this is the idea or intuition behind the iterative approach. So let's see the code in the next lecture.